Welcome to the skies over Colorado for May 2022. I'm Staff Astronomer John Ensworth of the Cherrywood Observatory, Little Thompson Observatory for Longmont Public Media. In astronomy news, I'm just leaving the James Webb Space Telescope up as the permanent title card for the first story. The 3-month process of aligning the James Webb Telescope instruments are complete, according to a statement that just came out April 28th. The mid-infrared instrument is cooled to under 7 kelvins, that's negative 47 degrees Fahrenheit. That's crazy cold. And the other Webb instruments are also operating at their temperature. All that remains is that the mirror segments themselves reach their operational temperature. If they're too warm, then they're glowing in the infrared as well, making the telescope somewhat blind. We have a sharpness image set from different instruments, and everything looks as good as it can be. They're very pleased with how it's all come together. Just as a reminder, it's made a almost 6-month journey from Earth out through a number of very risky deployment steps. It's now orbiting the L2 point beyond the Earth-Moon system, and that's where it's going to spend its life. Astronomers have discovered a black hole that gets a kick. Ripples in space-time show that 2 black holes that merged into one got a gravitational kick that sent them off into the universe from their original location at over 5 million kilometers an hour. The gravitational wave observatories LIGO and Virgo, both in the United States and Italy, or respectively, detected these black hole space-time ripples January 29, 2020. It takes a lot of time to do the math and try to figure out exactly what happened. So that is pretty amazing. And our final story for this month is Making Giants. Taking a look at an exoplanet system, and just wait, we'll talk about exoplanets momentarily. Astronomers have an infrared image of another star system forming. Dust is coming together to presumably make planets. The protoplanet, proto being a planet still forming, is currently 9 times the mass of Jupiter and is too far away from its parent star to have enough matter normally to form that. So they believe that a disk instability or a clump of stuff came together and collapsed very quickly, making this planet's formation begin. This is using data taken between 2016 and 2020, and again, lots of processing has to go into it, but as they said, this is exactly how a mathematical simulation of disk instability planet formation would happen. So they'll keep looking at it and looking for other explanations for how this big thing is forming, but it looks like that is a way the planets form. Big star parties. There's just a couple in May that we mentioned last time in Pensacola and Florida. Just didn't see much else out there. Maybe it's because a lot of schools are wrapping up their semesters that people don't try to take weekends out. But boy, in June things increase. This is just a sampling. We have the Cherry Spring Star Party in Pennsylvania. We have one in Michigan. The Pensacola folks are doing their things again. The Grand Canyon Star Party is June 18 to 25, which has been virtual for a couple of years. I didn't have to put the location there because it's at the Grand Canyon. And then closer to home, the Rocky Mountain Star Stare, Starry Meadows, about 2 hours southwest of Colorado Springs near Gardner, Colorado, is June 22nd to 26. And there are some more links if you can read those to explore these gatherings yourself. Your Astronomy 101 lesson for this month are exoplanets. Exoplanets is simply defined as any planet outside of our solar system, usually around another star, but there are rogue planets we might talk about someday in the future that could be kicked out of systems and drift among the stars or even between the galaxies eventually. But talking about exoplanets that we know of, Currently, we just passed the 5,000 mark. In fact, there was a celebration last month, so 5,014 confirmed. They usually get dropped in batches as programs publish everything that they've discovered over a period of time. So they added some 45 to the list and knocked it over 5,000. There are 8,887 candidates that are still being processed and checked up upon. Some of those you can actually, as a citizen scientist with the backyard telescope and some patience and training, add data to the data sets to try to confirm those or deny those. And those 5,014, and probably the candidates, I would have had to look at the article a little closer, are scattered among 3,764 separate stars or planetary systems. Just to give you an idea how new all this is, here we are in 2022, the first confirmation of an exoplanet around a sun-like star, which is actually dubbed a hot Jupiter. It's a big Jupiter in close to its star, like Mercury's orbit or closer, in our solar system, was only in 1995. There are numerous ground observations that have contributed to finding these, but I chose to mark here or list here the space missions that have contributed. The biggest hitter is the Kepler mission, which is responsible for this cone of discovery things around here. We've discovered lots in close using these other methods. Using microlensing, we've been able to see stuff between us and the galaxy's center. This is the Milky Way here. And there are at least 4 space well, 3 that are operational now, and James Webb will be joining that as soon as it starts to take data. The sky above your backyard. Well, in the evening it's kind of boring, except when the moon comes through. And the month begins and ends with a new moon. I called that a blue new moon last time. That's not an official term. That is a johnensworth term. Made in these videos. May 8th is first quarter, full moon comes mid-month on the 16th, the 22nd being third quarter. After sunset, Mercury is just barely visible in the early part of the month. It's drifting closer and closer to the sun each day. It's too close to the sun and even may be visible in the early morning sky by the end of the month. Mercury zips around the sun in 88 days, so it is always changing sides of the sky. Uranus is not too close to the sun to be seen this month. Here's our evening sky. Ceres is the largest asteroid, and you can find that. It's actually a dwarf planet, but you can find that with a telescope if you know where to look and check over a few hours or over a couple nights to see that it has moved. Here's Mercury very close. Pleiades are vanishing close into the sun too. Around midnight, still nothing up to see. It's nice and quiet out there. We have some Kuiper Belt objects, Make and Haumea out there, but if you can't find Pluto in your backyard telescope, you're not going to find those either. We do have our eclipse mid-month. We're going to talk about that in just a moment. That's our observing challenge. In the morning sky, it's a traffic jam. Starting rising about 4 hours before sunrise. Mars, Neptune, and Jupiter about 2.5 hours, and Venus is now a couple hours before sunrise. So everything's well placed in the morning sky. You just have to wake up to see it. Here's Uranus mid-month, just coming out of the glare. It's already hard to find, so being that close to the sun, it's probably not going to be visible. Here's Venus, Jupiter, Neptune, Mars, and Saturn, and even Pluto's in the morning sky, but that's a serious challenge for amateur astronomers. Better with big scopes or with photography. The sunrise backs up from 6 a.m. to almost 5:30 a.m. The sunset lengthens into the evening from about 8 o'clock to about 8:20 p.m. The length of the day goes from almost 14 hours to about 14 hours 45 minutes, so we gain about 50 minutes of light. The altitude of the sun at local noon climbs from 66 degrees to 72. It will max out around the 20th of next month as summer begins. Our feature object is going to be a double star. This time of year, the Big Dipper is high up in the evening sky, though looking upside down. Here it is after sunset. Here's north, here's the North Pole Point, and the Polaris just a little bit off of that. And up here is the Big Dipper. And Mizar and Alcor are a visual double star used as a eye test, even back to ancient times. Nicknamed the horse and rider, Mizar is just little, well, just off of 2 magnitude, sorry about that, 78 light years away, so it's very close. Its official designation is Zeta Major, and it's a double star with a second little star just 14 arcseconds away, so that's a telescopic double. The other little star is also a double star, so both Mizar itself, Zeta, and its companion are doubles. And then Alcor is going around that 4-star system in the center, but it's much further out and takes 750,000 years to orbit those 4 stars. So that's a really interesting system in the bend of the handle of the Big Dipper. Easy to find, a great eye test to look for. Your observing challenge: just can't pass up on the May 15th and 16th total lunar eclipse. It's not really the 16th, the penumbral part of the eclipse, or the shadow of the atmosphere of the Earth, ends past midnight on the 16th, but it all occurs for us, really, the show is on the night of the 15th, which is a Sunday night, but it doesn't keep you up too late. Let's take a look at some of these times. I prefer to not bring in what's called the penumbral part of the eclipse. It's just so dim for the average person to see, and for Colorado, the moon isn't even up at the time that begins. The partial eclipse, when you actually see a bite out of the moon, happens pretty close to the sunset at 8:27, but the moon is coming up at that point. The full eclipse, where everything is dark and kind of a reddish color, is 9:29 p.m. Mid-eclipse, the darkest time of the eclipse, is 10:11 p.m. The full eclipse ends, light begins to return to one edge of the moon at 10:54 p.m. basically, and the partial eclipse ends at just a few minutes before midnight. Oh, just about as perfect time as you can to see an eclipse. Just fantastic. Now the moon is reddish because of basically the glow of sunlight coming through the atmosphere all the way around the edge of the Earth, because the moon is in the Earth's nighttime shadow. So if you were a moon person sitting on the face of the moon looking back at the Earth, you'd have this big red ring around it that is all the sunsets occurring at the same time. So that's kind of a neat way to think about it. So if the atmosphere is very clear, we haven't had a lot of volcanic activity or giant forest fires and such, the moon will be a more pale orange, or even kind of yellowy orange. If we've had major eruptions, lots of fires, say around the equator and like that, then you might get a very dark brick red or even gray, almost faintly red, almost invisible moon. I've seen one of those back in the 90s. So there it is in the low in the southeastern sky, so it rises over here and heads on up, and it's going to be low, so you're going to have to get a place where you don't have trees in the way or buildings. I think I'm going to be able to do it from my backyard at the Cherrywood Observatory. I have about 10 telescopes I can put out, so I'll put out a number of them in the yard, weather permitting. If you want to take a look to see if I'm doing it, I'll try to put together a web page at bikerjohn.com. That's my personal website. And if the weather looks iffy, I can put an update there. You can use my email at the end, johnensworth@gmail.com, if you want to come by and say hi. If you've enjoyed these shows and just want to see the actual Cherrywood Observatory, this is a great time to do it. So feel free to contact me, and I'll give you an address. So a few of the details about this. This white circle is the totality circle of the Earth's shadow, so you're completely in the nighttime thing, nothing sticking out, and so it is absolutely at mid-eclipse in the middle of that, 100% obscuration. Duration of that totality is pretty long, 5 hours and 19 minutes. Duration of the eclipse is 5:19. The totality is only 1:25, which is still very notable, and the partial durations add up to 2 hours and 2 minutes. Take a look at some astronomy events near Longmont. May 19th, the Longmont Astronomical Society is talking about the Atacama Large Millimeter submillimeter array and the game-changing science. Dr. Joe Pesce, I'm going to have to meet him someday and ask him how he pronounces his last name. Longmont Astronomical Society's Boulder County Open Space. I can't, again, find observation time for that. I may want to reach out to them. Maybe I should do that next month and say, are you doing this? It's probably later than this. It's too light, but they don't have any times out for me. Little Thompson Observatory is reopening. 2 scheduled events. You have to get on the website and make a reservation and wait for that to be approved. They'll contact you about your party and details and like that. Estes Park Memorial Observatory is open Friday, Saturday, Sunday, Monday to 12 people or so, and check their site for details. Northern Colorado Astronomical Society has McKenzie FerrieImaging X-Ray Polarimetry Explorer Observatory, so that would be a really fun one to do. I think that's only through webcast. FSCI Planetarium has a bunch of different shows now being advertised on their site, and they also have laser light shows are back. I saw Pink Floyd there, so might have to go do that. I didn't see any open house nights for the observatory at University of Colorado Boulder and in May, and that may be because at the end of the semester everything is so crazy and finals and things like that. They are going to have a free lunar eclipse party on the night of the 15th, running from 8 to 11 p.m. So if you don't want to come see the Cherrywood Observatory, you could go there as well. But they do have a number of June and July and even August open house nights. So yeah, they're going to be late, 9 to 11 p.m., but that would be a great thing to do sometime this summer. And finally, our historical misstep in astronomy, in about 30 seconds, would be the claim that neutrinos are seen traveling faster than light. CERN operates the Large Hadron Collider, which is underneath Switzerland and France. You may have heard of it. The Higgs boson was announced there a few years back. And for over 3 years, the instrument called OPERA, which is off-site about 730 kilometers away, does watch neutrinos generated by the Large Hadron Collider. And these things stream through the Earth like nothing. They don't even really see that the Earth is there. And they measured 16,000 neutrinos roughly that made what should have been a 2.43 millisecond trip get there about 60 nanoseconds, which is a very, very small amount of time, faster than they were supposed to if they were just traveling the speed of light. That's about 0.002% too fast. Now, neutrinos are tiny, electrically neutral particles produced in nuclear reactions, and I don't want to go deeper into what a neutrino is here, but that's good enough. Another experiment called Icarus showed them traveling at the speed of light within error by packing the pulses differently. Then a timing error was finally found, a faulty connection at the point from which the light from a fiber optic cable synchronized with a global positioning system's time signal into the master clock made things tiny bit off. But hey, this is tough stuff to do. These measurements are difficult, and they had to experiment and find out what was going on. If it had turned out to be that these little particles could go faster than light, that would have changed everything about what we understood in physics. Instead, we just found it was a mistake. There is an image of the part of the beamline of the Large Hadron Collider deep underneath Switzerland and France. If you have any additions, corrections, or want to come see the eclipse, or just meet me and take a look at the Cherrywood Observatory, contact me at johnensworth@gmail.com. This has been the Skies over Colorado for May 2020. Keep looking up.